Paper 5, Section A, the first question. A physical quantity of dimension of length that can be, the first question is a physical quantity of dimension of length that can be formed out of CG and C square E square by 4 pi epsilon naught C is velocity of light. G is universal gravitational and three quantities are there. One is C, one is G, and another is E square by 4 pi epsilon naught. Where C is the speed of light, G is universal constant, gravitational constant, and E is charge. Both the methods you can apply actually. Either you take one of the option and check its dimension, which is coming in the dimension of length by putting the values of the dimension of the given quantities, or you can also take that some C to the power x, G to the power y, and E square by 4 pi epsilon naught to the power z, and from equate them with dimension of length. Then you can prepare the equation, and after preparing that equation, you can claim that xyz value of xyz can be calculated, and from that you can find the exact expression. That is also possible. So dimensional analysis, either do the dimensional analysis or check the dimension of each and individual options, and you will find the answer. Two procedures are there. Either use dimensional analysis or use the individual options and check which option matches with the dimension of length. Okay? Now, the question number 2. Preeti reached the metro station and found that the escalator was not working. She walks up the stationary escalator in time t1. On other days, if she remains stationary on the moving escalator, then the escalator takes her up in time t2. The time taken by her to walk up on the moving escalator will be. This is a problem of relative velocity. Problem of relative velocity. Because if he is moving over the stationary escalator, then he is moving with the speed with respect to the ground, and if he is moving over the running escalator, then his velocity with respect to the escalator is 0, but with respect to the ground his velocity is the velocity of the escalator. But if he runs over the moving escalator, then you have to calculate its relative velocity. So from the calculation of relative velocity you can solve the problem. So just you have to read that portion of relative velocity. Clear? The thing is that if the escalator is stationary and you are moving over it, then you are moving with your own velocity with respect to ground. Now if you are standing on the escalator and escalator will take you to the top, then you are moving with a velocity which is the velocity of the escalator itself with respect to the ground. So if you are moving over the escalator and reach that point, means your velocity is measured now with respect to escalator. Because escalator is also moving, you are also moving. So velocity of you with respect to escalator has to be calculated for this, then you can find the time. Okay? Because escalator is moving up, you are also running up. So you will take shorter time for both these cases. Previously what you have done, escalator stationary, you are running over the escalator, so you take certain time. Second time, think about when the escalator is functioning normally, you are standing in the escalator and the escalator is taking you to the, suppose it takes certain time. But when the escalator is moving and you are also running, so it will take less time to reach the top. So that's why relative velocity is definitely increased in that situation. Since the relative velocity is increased, you will get a short time to reach to the top. So you have to study once the relative velocity portion to solve this problem. Clear? So write this as a hint. The relative velocity has to be calculated for the calculation. Question number 3. The x and y coordinate of the particle are given. Particle at any time are x equal to 5t minus 2t square and y equal to 10t respectively. X and y are in seconds. The acceleration of the particle at t equal to 2 seconds. Anyone? Any idea how to solve? Motion in 2D. This is a motion in 2 dimension. So you have to find the acceleration, magnitude of acceleration. So first what you will do? First you have to calculate the accelerations x component, then accelerations y component, and then write a equal to root over of ax square plus ay square. Because any vector, if they are resolved into perpendicular components ax and ay, then their magnitude should be root over of ax square plus ay square. Now, first thing is given that x equal to 5t minus 2t square. T square. And y is given 10t. Just calculate dx dt first. That will give you the x component of velocity. What will be the velocity? Derivative of this one. That is 5 minus 4t. So we require accelerations x component, so we have to differentiate it again. d2x, dt2. This one will be 0, this one will be minus 4. So this is acceleration vectors x component, minus 4. Unit I will write at the end. Similarly, calculate dy dt first. See, dy dt will give you constant. Okay. Then d2y dt2, this one will be 0. Means ay, accelerations y component will be 0. Correct? Then, at time t equal to 2 seconds, what is the acceleration? So, acceleration will be root over of ax square plus ay square. So, it will become minus 4 meter per. Now, you can say why you are writing minus 4. Because if you put the value of ay, it is itself 0. So a should be equal to ax, and what we have find ax? Minus 4. So that's why I put minus 4. Because this is similar to a projectile motion, which is moving under an acceleration of 4 meter per second square downward. Because if the gravity is 4 meter per second square, then this motion represents a projectile exactly under gravity. Because see the equations, y coordinate, so x coordinate is only value and x and y coordinate has to be interchanged. Vertical coordinate is x coordinate, horizontal coordinate is y coordinate. Then it is similar to a projectile. Okay, so this is the technique. So since it is a 2D motion, x and y are given in terms of t, you have to only differentiate to find the x component of acceleration and y component of acceleration. Then a equal to root over of ax square plus ay square. Ay is directly 0, so you can put 0. So a will be equal to ax, and ax we have already found minus 4. Okay. Now, next question. Question number 4. Consider a drop of rain of water having mass 1 gram falling from a height of 1 kilometer, it hits the ground with a speed of 50 meter per second. Take G constant with value 10 meter per second square, the work done by the gravitational force and the resistive force of air. How to solve this problem? See, first case, definitely the concept of work power energy is required to solve the problem, because work done or energy that has to be calculated. Now think, it is dropped from a height of 1 kilometer. It is dropped from a height of 1 kilometer. So from 1 kilometer it is falling. So at the height of 1 kilometer it has some potential energy. And this potential energy is converted to kinetic energy when it is about to reach the ground. Then first we can consider the potential energy should be mgh. So write mgh as the potential energy when the drop is at the top point. mgh. This is the potential energy. Now as it comes down, this energy is converted to kinetic energy, and just consider its kinetic energy at the bottom will be half m v square at the bottom, because when it about to reach the ground, then height will be 0. In that case potential energy will be 0. So this will be the expected value of V. But this will occur when there is no resistive force. If there is no resistive force, then this velocity will occur. So this velocity we can calculate easily from the given data. V equal to root over of 2gh. But what is the velocity just before touching the ground? That is mentioned in the question, 50 meter per. So this velocity is expected to come greater than 50 because we have neglected the resistance of air. So since the air resistance is present, the velocity is decreasing. Clear? Then what you have calculated? Work done by gravitational force. Work done by gravitational force is already mgh. So first part is work done by gravity. That will be mgh. Then work done by resistive force. So how to calculate work done by resistive force? This is how much? Work done by gravity minus half m V prime square. V prime is the value that is given. What is that value? 50. So definitely half m V prime square is less than 50. So remaining part is the work done by friction force. And work done by friction force always have the negative sign, because friction is in the opposite direction, displacement downward. So the value that you get, just calculate it, just put the negative value in the answer. Or you can also write half m V prime square minus LT. That is also possible. So I am calculating the loss. Since it is loss in energy due to the air resistance, then before the loss I can put a minus sign. So what happens in this case? If there is no resistance, it is expected to have this velocity at the ground, but it has a velocity 50 meter per second, not the value calculated from this. Then why the value changes? Value changes because the resistive force of air offers some resistance to the falling drop, and as a result its velocity when it will reach the ground, it is 50. Because if you calculate this one, this will be more than 50. And that is possible if there is no air resistance. Clear? So due to air resistance, velocity is 50, otherwise it is more than 50. Then work done by gravitational force is definitely mgh, and this part is the half m v prime square, where v prime is 50. So remaining part is the loss. So loss is due to resistive force, and you are asked to calculate the work done by resistive force also. But the resistive force is actually viscosity in this case, in the upward direction, and body is falling in downward direction. So angle between them is 180. So I have to put a minus sign when we calculate the work done by the resistive force. If it is said that what is the loss in energy, I will write just this positive value. Okay? So write this one. Which of the following statements are correct? Center of mass of a body always coincides with the center of gravity of the body. Center of mass of a body is the point at which the total gravitational torque on the body is 0. A couple of body produces both translational. A couple on a body produces both translation motion and rotational motion. Mechanical advantage greater. Which one? This is an information based question. Question number 5. First tell me whether statement 1 is correct. Center of mass of a body always coincides with the center of gravity. Center of mass of a body always coincides with center of gravity. Is it correct? No. Give one example where it is not correct. Suppose for this marker, can I claim that center of mass and center of gravity are at the same point? In this mark, for this marker, I can assume that center of mass and center of gravity at the same point, are the same. For this marker I can assume, but we cannot assume it for Himalaya, because for a massive object whose dimension is too large, then from the bottom of the Himalaya up to the top of the Himalaya mountain, G is different. Acceleration due to gravity is different. So that's why center of gravity and center of mass are different points. But for this marker, if I consider this point is the center of mass, and you are saying that G is different from this point to this point, I can ignore, because this much length will not produce any change in G. So for this small object, over its length, over its dimension, G is almost taken to be constant. There is no such change in G over its dimension. But for Himalaya, that is so large. So, and due to its huge dimension, at different point G will be different. So you have to consider different G. So center of mass and center of gravity for massive body will be different. Massive means not only this one. Even for a train, I can consider it's a very small body compared to the mountain. Okay. Now, so first option, first statement is incorrect. Second statement, check. Center of mass of a body is the point at which the total gravitational torque on the body is 0. It is true. Why it is true? Total gravitational torque on the body is 0. Why it is true? Now, any one of you tell me what is center of mass? What is center of mass? Just tell me what is center of mass? Anyone? Because center of mass and all this entire rotation topic is actually very conceptual, and most of the students have facing this difficulty. They can calculate the problem, they can write the formula, but if it is asked that why center of mass is required and what is center of mass, then they will feel trouble. You know the formula of center of mass. If I give some problem giving some masses and their location, you can immediately put in the formula and find the result of the center of mass. But what is center of mass? See, center of mass is actually initially called the balanced point. The balanced point of a body. Now what do we mean by balanced point? See, this marker, if I try to put my finger here and say that about this point I can hold the marker perfectly horizontal. Is it possible? It will definitely fall in this. So this can't be the balanced point. But if I consider almost this point, there is only one point about which this marker can be placed horizontally. So that is the balanced point. Means you can say that entire weight of this is actually passing through this point. So if I put my hand over here, it will become horizontal. But wait, I use the term weight. Weight means it should be center of gravity. But for this small object, center of mass and center of gravity are same. So I can as well say center of mass is the balanced point. Now, I will consider only the cases of the small object where center of mass and center of gravity are same. So for daily life application, center of gravity and center of mass are same, and by concept of center of gravity you can explain center of mass. Later I will explain what is the difference and what is the general method of center of mass finding and why it is so important. Next, one more thing. Suppose I have this bunch of question paper or anything. Now, suppose this one is perfectly rectangle, so we know that the center of mass will be at the, if it is a uniform rectangular sheet, then center of mass will be at this central point, that means the intersection point of the two diagonals. Now, how to measure them experimentally? How to find the location of the center of mass experimentally without using any geometry? Suppose it is non-uniform. Mass distribution is non-uniform. Then you cannot claim that at this intersection point of the two diagonal center of mass lines. For uniform, it is true. But for non-uniform, it is not true. Then, what you will do? First, take any point on this paper and release it like this. Hang it from this point. Okay? So, if it is hanging from this point, then What is the direction of G? Downward. So from this point, just put its downward straight line. Now, take any other point on this lamina and hang it same as before. Suppose this one. This one. Again you know the direction of G. So from this point, pull it. Another line. These two lines will definitely intersect at some point. Then that intersection point is the center of mass. That intersection point will be the center of mass. So what we have done first, like this, then like this. Now check why it is coming. If I want to hang this lamina like this, can it be hanged by putting a holding this 2 point like this? Can it be hanged in this situation? No. Like this. Why it is coming? Because center of mass must come definitely under this point. Because weight for small body, weight is passing through center of mass. That's why it is also called center of gravity. So that line of gravity should pass through this point. So this point must not be, hanging point must be around the same line, and the center of mass or center of gravity, whatever be, should be just below this line. It cannot be above this line. You cannot hold it like this. If you are hanging something, about it is just a point. You cannot put it like this. It will definitely come in this way. Just about a point. Don't think that I am holding like this much, not this much. Only just a point. So about a point, it will definitely roll, and it will not stay in this position. It will come here, and center of mass will lie below the hanging point. Always. There is no exception. Center of mass always lie below the hanging point. Clear? Now, I consider two arbitrary hanging points, and center of mass in both the cases lie below that line. That's why I draw two lines, and two lines were intersect. That is the common point. That is the center of mass. That is the experimental technique to determine the center of mass for irregular body, for which we cannot do any calculation. Clear? So that's why you can consider that if the hanging point is the center of mass itself, then it can be balanced. So that's why the name comes balanced point. If the hanging point is the center of mass itself, then the body will be perfectly balanced. Which principle is used? That principle is used in beam balance. When it is exactly passing through the center, the beams will become horizontal. Now, for other parts, so this is the explanation of center of mass on the which is based on center of gravity, because I uses the hanging point to actually balance the load on both sides. So that is actually center of gravity, but for small objects, center of gravity and center of mass are same. Now, what is the utility of center of mass? Why it is important so much in mechanics? Let us consider this marker. I consider it is just like a dumbbell. If it is a dumbbell-like structure, then you know that this side there is a mass. Say M1, this portion there is a mass M2, and two masses are separated by a distance. Two masses are separated by a distance. Now consider the distance is just like a rod which is massless, but the length between two mass, this gap between two mass is fixed. Now hold any one mass, suppose M1, and throw it at an angle 30 degree or 60 degree with horizontal, just like a projectile motion. So this will rotate like this, and it will fall. Now see the complicacy of the motion of M1 and M2. So entire motion is very complicated. Now I am asking, what is the velocity of mass M2 with respect to the ground in the entire motion? What is the velocity of mass M2 with respect to ground? It's performing a very complicated motion, not a perfectly projectile motion, not a perfectly circle, not along any straight line. See what happened. M2 is this mass, black. Like this. So motion of M2 with respect to the ground, it looks almost impossible to calculate. But when you use the concept of center of mass, it will become very easy. That's why center of mass is important. Why? So these two masses are M1 and M2. You can consider that center of mass lies somewhere here at this point. Center of mass lies. Now check. Whenever you are throwing, this particle is rotating like this about the center of mass, and you can see that in the entire two particle system there is only one point, only one, whose motion is perfectly like a projectile, and that point is the center of mass. So for many particle system, if entire mass is concentrated at the center of mass and entire force is acting on that particular mass, the particle, a single particle will represent the motion, can represent the motion of the entire system. So that's why center of mass is used. Because for a single particle having total mass m1 plus m2, you can easily calculate the trajectory, velocity and all these things, because you have already studied it in projectile motion. Now, what is our main aim? To calculate the motion of velocity of particle m2 with respect to ground. And what we have calculated? The motion velocity of center of mass with respect to ground. That we have calculated. Now, change the origin of the observer to the center of mass from the ground. Now consider the observer is sitting on the center of mass. Now if the observer is sitting itself at this point, then observer is looking at M2. What will be the motion of M2? With respect to the center of mass? Perfectly circular motion. Perfectly circular motion about center of mass. Clear? For circular motion you know all the things. So now calculate the velocity of M2 with respect to center of mass. So what you have done? Velocity of center of mass with respect to ground, VCG, that you have calculated, which is coming from a projectile motion, because center of mass is going just like a projectile, parabolic path. So you have calculated this one, V, center velocity of center of mass with respect to ground. Next, what you have done? You shift the observer to the center of mass, and if the observer is shifted to the center of mass, then motion of M2 about center of mass is just like a circular motion. Now from the circular motion's calculation, you calculate V of M2 with respect to center of mass. Then just subtract. What you will get? Velocity of mass M2 with respect to ground. Because the velocity of center of mass is actually cancelled. So you are getting velocity of M2 with respect to ground. That we want to calculate. So once you introduce the concept of center of mass, the remaining problem is just a relative velocity calculation. So that's why center of mass is important. Here. So initially from the ground, if you try to calculate directly the motion of M2, it is very difficult because it is rolling and as well as moving in a projectile. So we split the motion into two parts, where the center of mass is considered as a single particle. It is moving in a projectile. Then after that we consider the observer is shifted to the center of mass. Then with respect to the motion of M1 or M2 is simply a circular motion. And we know the circular motion and projectile motion, velocity and all these calculations very well. Then we split the entire motion into two parts. One is projectile, another is circular motion. Then first calculate velocity of center of mass with respect to ground. Next calculate velocity of M2 with respect to center of mass. Then subtract. Then this relative velocity calculation will give you velocity of M2 with respect to the ground. Similarly, we can find velocity for M1 with respect to ground by taking the same procedure. VCG first we will calculate, that is common for both. Then we calculate velocity of M1 with respect to center of mass, then subtract. And you will get velocity of M1 with respect to the ground. So that's why center of mass is important. Because it may happen that the body has no mass, system has no mass at the point of center of mass. Suppose a circular ring, where is its center of mass? At the center, uniform circular ring. But is there practically any mass at the center? No. But center of mass is that hypothetical point, but which is extremely important to analyze this complicated motion. Clear? So this is the concept of center of mass. Okay. Now, what about the answer to this question? Question number 3. A couple on option number 3. A couple on a body produces both translation and rotational motion in a body. Definitely not. Because couple in a body can only produce torque. Couple in a body can only produce rotational motion, but not the translational motion, because couple means two equal and opposite force, anti-parallel. Just anti-parallel like this. They are not along the same line. So they cannot produce any translation. They can only produce rotation. Last one. Mechanical advantage greater than 1 means small effort can be used to lift large load. That is also correct. So question number option 4 is actually correct. Both 2 and 4, these two statements are correct. Statement number 2 is correct. Statement number 4 is also correct. Okay. Next. Question number 6. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 cm is free to rotate about its geometrical axis. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 Newton? What is required to solve this problem? Moment of inertia and torque, and this calculation is required. See how. I will consider the top surface of the cylinder. Cylinder is like this inside. Now, its mass is given 3 kg, so weight is like this, and it is a rope is wound around the hollow cylinder of mass 3 kg and radius 40 cm. is free to rotate about its geometrical axis. It is rotating about its geometrical axis, and tension is given here. Because the rope is wound like this, so tension will act like this, T, and it is rotating about this point. Pulled with a force of 30 Newton, you have to find out the angular acceleration. Okay, first. Now, angular acceleration is denoted by alpha. Now, how can we calculate the angular acceleration? Torque equal to moment of inertia into angular acceleration, which is Newton's second law in rotational motion. Because second law in linear motion will be F equal to ma. But in case of rotational motion, F is replaced by torque and M is replaced by I and A is replaced by alpha. So torque equal to I into alpha. Now think, there are two forces. Which force can create a torque above the axis of rotation? Two forces are there, mg and tension. And among these two, between these two forces, only one can produce a torque above the axis of rotation. Only tension, because line of action of mg passes through axis of rotation, so it cannot produce any torque because its distance torque r will be 0. So only the force RT can produce torque. So I can write, this is radius, so torque of T is T into R equal to I alpha. Then for hollow cylinder, put the value of expression for I and calculate. T is given in the problem, R is also mentioned in the problem. Then for hollow cylinder, calculate moment of inertia and put to find alpha. So just write down as a hint what I have written, such that you can make the notes and solve the problem. Okay. Question number 7. A tube with both ends open to the atmosphere is partially filled with water, oil, which is immiscible with water, is poured into one side until it stands at a distance of 10 mm above the water level on the other side. Meanwhile, the water rises by 65 mm from its original level. The density of the oil is. How to calculate? So which law is utilized here? See, just check the question paper. Point B and C are at the same horizontal level. Point B and C are at the same horizontal level. And just check, below that line BC, entire liquid is a single liquid. Only water. Then pressure at point B will be equal to pressure at point C. So pressure at point B is height of the oil column into density of the oil into G. Pressure at point C will be height of the water column into density of the water column into density of water into G. From that you can calculate P equal to H dG. That is required, and at the same horizontal level, pressure given by both the liquid column will be same. Because it's a static liquid, so at the same horizontal level, pressure should remain same. And I consider the point BC because below BC, entire liquid is one liquid, that is water. So on the level BC, at any point B and 2 points B and C, pressure should be same. So at point B, pressure is created by oil column. At point C, the pressure is created by water column. So these two will produce the same pressure. The height of the water column suppose H2 and height of the oil column suppose H1. Density of water is D1, density of water D2, and density of oil D1. Then H1 D1 G equal to H2 D2 G means H1 D1 equal to H2 D2. So from that you can solve the problem. It is a problem from hydrostatics, the fluid mechanics or hydrostatics portion. So from that you have to calculate the density of water. H1 D1 equal to H2 D2, that is the formula. So H1 for I consider oil, D1 is density of oil, H2 is the column of water, and D2 is the density of water. Density of water is the standard value, and height of the two columns you know. Then from that you can find D1, that is the density of the oil. Question number 8. A spherical black body radiates 1000 watt power at 450 Kelvin. If the radius were half and the temperature is doubled, power radiated will be which portions? The Stefan-Boltzmann law. Stefan-Boltzmann law, power and adjacent portion where power radiated by a black body is discussed is directly proportional to the fourth power of temperature. So from that you can solve the problem. How many of you remember Stefan's law? Stefan-Boltzmann law, the radiation from a black body and all these things, emissivity, absorptivity. That is in the portion of heat, Newton's laws of cooling, Stefan's law, Boltzmann law. There are two more laws, Planck's law, Wien's displacement law, and all these things. That portion you have to study and prepare the notes for this question. Question number 9. Two rods A and B of different materials are welded together as shown in figure. Their thermal conductivities are K1 and K2. The thermal conductivity of the composite slab. First, two slabs are there. They are connected between same temperature difference T1 and T1 minus T2. So thermal temperature difference is similar to the thermal voltage. Temperature difference is called the thermal voltage. So they are connected between same thermal voltage, means they are connected in parallel. So in parallel conductivities will add, because conductivity is following opposite law of resistance. So it will just add. Parallel means addition. And if they are series, then 1 by K will be 1 by K1 plus 1 by K2. Resistance and this conductivity will follow the opposite law. Question number 10. Thermodynamic processes are indicated in the following diagram. Match the column. Process 1. Process 1. Tell me, what is process 1? In process 1, volume is constant. See, process 1 is vertically downward. Vertically downward means pressure is changing, but volume remains constant. So this is called isochoric process. volume constant. Process 2. What is process 2? Iso. Process 1 isocoric. Process 2, pressure is changing, volume is also changing, but very sharply changing. That is called adiabatic. Process 2 is adiabatic. Process 3, pressure is changing, volume is changing, but the slope is not that much fast. So it is isothermal. Process 4 is isobaric because pressure remains constant in process 4. See, so isobaric process and isocoric process, that is easy to determine because isobaric means pressure remains constant and isocoric means volume remains constant. But how I distinguish between the other two as isothermal and adiabatic? See, isothermal process. Which law is obeyed in isothermal process? PV equal to constant. Suppose C. PV equal to constant. This is isothermal process. Adiabatic process means PV to the power gamma equal to constant. Okay? And value of gamma is greater than 1. Because gamma means Cp by Cv. Cp is greater than Cv. So in any case, gamma will be greater than 1. So this is adiabatic process and this is isothermal process. I want to calculate the slope of PV graph. So the diagram that is given, what is the x coordinate? P. And what is the y coordinate? P. Then slope means dy dx. So dp dv is the slope in this particular case. So I will calculate dp dv for both the cases. From this I can calculate the derivative directly, but better to use logarithm first and then differentiate. If you apply logarithm on both sides, then log p means natural log plus log b equal to log c. Log p plus log b will be log c. Then differentiate both sides. This term will be dp by p. This will be dv by v. But c is constant, so its derivative will be 0. So dp by p plus dv by v equal to 0. Then write dp by p equal to minus dv by v. Then dp dv equal to minus p by v. That is the slope of isothermal curve. Slope of isothermal curve. Okay. Now similarly I will calculate the slope of adiabatic curve. Check. Take log on both sides, then it will be log p plus gamma times log v equal to log c. Done. Log p plus gamma log v equal to log c. Then again differentiate dp by p plus gamma dp by v equal to 0 means dp by p equal to minus gamma dp by v. So dp dv adiabatic, that is coming minus gamma times p by v minus gamma times p by v. But minus p by v means this one. So from this can we conclude that dp dv adiabatic equal to gamma times dp adiabatic slope equal to gamma times isothermal slope, and gamma is greater than 1. So which curve slope is greater? Adiabatic curve. Adiabatic curve slope is greater. Slope greater means it is steeper. Slope means this one. So this is, if this is isothermal, this will be adiabatic slope. So this one is running faster. Slope, higher slope means it makes greater angle with horizontal axis. So obviously this will, adiabatic curve will make more slope with more angle with horizontal axis, means it is faster. Whether isothermal curve is not so faster. Clear? Because from this calculation, dPdV adiabatic, this comes minus gamma into P by V, but minus P by V we have already calculated. That is dPdV isothermal. So I put this one here. So we will get dPdV adiabatic equal to gamma times dPdV isothermal. Gamma is greater than 1. So obviously slope of adiabatic curve is greater than slope of isothermal curve. So now check the two options, that is process number 2 and process number 3. Why I consider process number 2 as adiabatic and process number 3 as isothermal? Because 3 has less slope than 2. Question number 11. A Carnot engine having an efficiency of 1 by 10 as heat engine is used as a refrigerator. If the work done on the system is 10 joules, the amount of energy absorbed from the reservoir at lower temperature is. See, normally heat engine absorbs heat energy from higher temperature and rejects it to the low temperature. But since it is used as refrigerator, then it will extract energy from the cold reservoir and transfer it to the hot reservoir. So efficiency is given. Now you have to take this coefficient of performance and calculate. That I said in the another problem in the last class. For refrigerator, instead of efficiency, we have to take it as coefficient of performance, and then you can calculate. So just write that coefficient of performance has to be calculated for solving the problem. The two nearest harmonics of a tube closed at one end and open at the other end are 220 Hz and 260 Hz. What is the fundamental frequency of the system? So both pipes are open or closed? Closed pipe, because one end closed means closed pipe. So for closed pipe, two nearest harmonic. Nearest harmonic means two consecutive harmonics, and two consecutive harmonics are in closed pipe. Only odd order harmonics are present. Even order harmonics are not present in closed pipe. All order harmonics are present in which pipe? Open organ pipe. All order harmonics are present, but in closed pipe only odd harmonics are present. So from that calculation you have to find out the fundamental frequency. So you have to read this portion of closed and open organ pipe and to prepare the notes and then solve the problem. Okay. Now, question number 30. Two cars moving in opposite directions approach each other with speed 20 meter per second and 16 meter per second respectively. The driver of the first car blows a horn having a frequency 400 Hz. The frequency heard by the driver of the second car. This is a problem of Doppler effect. Doppler effect is still in the syllabus. It is eliminated. So this is a problem of Doppler effect. You can write the hint as Doppler effect for both source and observer. Both are moving. Source and listener, both are moving. Question number 14. A capacitor is charged by a battery. The battery is removed and another identical uncharged capacitor is connected in parallel. The total electrostatic energy of resulting system is decreased by a factor of 2, remains the same, increases by a factor of 2, increases by a factor of 4. First, tell me whether it will remain same, increase or decrease. Decrease. Why decrease? Just think physical. Can it decrease? Will it remain same or will it increase? What you have done? You have charged the battery. Charge the one capacitor by using a battery and then disconnect the battery and at the position of the battery put another identical uncharged capacitor. Then first thing, when you put the uncharged capacitor in parallel with the charged capacitor, is there any charge sharing? Definitely. Because this capacitor will behave like a battery and it will supply some charge to the uncharged capacitor. Now, if there is sharing, there is a flow of current. Because how charge base will share from one charged capacitor to the another uncharged capacitor? Definitely some current will flow. Charge flow means current. Now, if current flows, there is Joule heat loss, I square RT, that you have studied in class 10 also and in 12. Joule heat loss will be there. So electrostatic energy will definitely decrease. Electrostatic energy means the energy stored in the capacitor. If some energy is lost in the form of heat, then that is not stored in the capacitor. So definitely now after settlement, if you calculate the electrostatic energy of the two capacitors total, that will be less than the initial value. Because some energy is lost in the form of heat. So definitely it will decrease. Now from the calculation, you have to find out whether it is decreased by 2 times, decreased by 4 times or clear? So first physical reason you have to understand why it will decrease and then go for the calculation. Because whenever there is a sharing of charge, there is a flow of current. Current flow means there will be Joule heat loss. Because whenever current flows through a wire, there is a heating effect. You cannot stop that heating effect. So if there is heating effect, so where from this energy will come? From the initial electrostatic energy, some part is converted to the heat energy. Then remaining part of electrostatic energy is decreased. So definitely there is a decrease in electrostatic potential energy. So that you have to calculate. Now already the two conditions, that is whether it is increased or it will remain same, that has to be cancelled. Nullified. So you have to focus on the decrease options and now you have to calculate to find whether it is decreased by 2 times or it is decreased by 4 times. That will come from the actual calculation. Okay. So whenever you will solve the MCQ, first try to eliminate the options. If you can eliminate 2 options or any, then your answer, probability of getting the correct answer will be increased. probability of getting the correct answer will increase definitely. If you can cancel the two options from the beginning, from the basic logic or basic concept, then try for the particular answer. Question number 14 that we have discussed. 15. The resistance of a wire is capital R ohm. Hello? It is not working? Oh. It is on. Oh, power button is blinking. Hello. Okay. Question number 15. The resistance of a wire is capital R ohm. If it is melted and stretched to n times its original length, its new resistance will be. So total volume remains same because total mass remains same, and answer will be n square R. It is very common and easy question. Okay. Now,
sorry for interrupting.
question number 16. A potentiometer is an accurate and versatile device to make electrical measurements of EMF because the method involves potential gradient, a condition of no current flow through the battery, a combination of cells, galvanometer and resistance cells. Which one? Option 2 is correct. A condition of no current flow through the battery. Because potentiometer measures EMF, and EMF means the potential difference between two terminals of a cell in open circuit condition. Open circuit condition means no current will flow. So potentiometer uses that condition for the measurement of the EMF. That's why it is accurate to measure EMF. Because in case of voltmeter, it actually requires current for the measurement, but in potentiometer current flow from the battery will be zero. In that case we can measure the proper EMF. Next, question number 17. An arrangement of three parallel straight wires placed perpendicular to plane of paper carrying some current I along the same direction, carrying same current I along the same direction as shown. Magnitude of the force per unit length of the middle wire P is given by. Parallel current carrying wire will repel each other or attract each other? Attract each other. So all the wires will attract each other. So their attractive force on the middle wire. This is the middle wire. This is one wire. This is another wire. So this is attractive force along this. This attractive force is along this. So resultant force is around this. Okay. So this first current carrying wire will attract the middle wire. Wire is like this. Second current carrying wire will attract this middle wire along this direction. Attraction means towards them. So these two forces are towards them, and net force will be along this direction. So you have to take the vector sum. And for the long straight infinite current carrying wire, we can only measure the force per unit length, not the total force, because total force is actually infinite, because the wire is infinitely long. And if you remember the formula, then force per unit length for any of the wire is calculated mu naught I1 I2 by 2 pi into distance between the wires. You remember or forget? Remember? How many of you completely forget this part? Okay. So I will show and solve the problem, because when we discuss this one, some other portions of the theory I will also discuss. Suppose there are two parallel current carrying wires. Suppose this is I1, this is I2, and distance between them considered as R. Then we know that around a current carrying wire, a magnetic field will generate. From whose experiment it was first discovered? Who discovered it? Oersted experiment. From Oersted experiment, it was first discovered that around a current carrying wire, a magnetic field will be produced. Okay. Then, what will be the direction of that magnetic field? That we can find from Ampere's swimming rule. Ampere's swimming rule: a swimmer's left hand north pole of a magnetic needle, if placed, it will deflect towards the swimmer's left hand. That is called Ampere's swimming rule, and from that we can determine the direction of that magnetic field. There are many other methods: Fleming's left hand rule, right hand rule, all these things, and most of the time students are getting confused with so many directions and so many rules. Left hand rule, right hand rule, corkscrew rule, all these things are there. So it is better not to remember any rule except the cross product. Okay, except cross product. Just cross product you have to remember, and on the basis of the cross product you can find any direction. No need to bother with so many rules. See, this one is a current carrying wire. So at this point some magnetic field will be produced. So how to find the magnetic field produced, direction of the magnetic field produced? I want to use cross product first, simply by using Biot-Savart law. Biot-Savart law. What Biot-Savart law tells? If this is R, this is I, you can consider a small element of current at this point, small length. So it is saying that B equal to, I consider small element dV, that is equal to mu naught I PL cross R cap by r square by 4 pi. That is in the Parseval's law in differential form. Then what is the direction of r cap? Definitely this one. This one is I. So just ideal cross r cap. What is the direction of my thumb? Ideal. I place all my 4 fingers along the direction of current. Then rotate this in the direction of r. So what is the direction of my thumb? Into the board. So at this point field will be into the board. Place and then rotate. My thumb is directed into the board. So at this point field will be into the board. Encircle, cross. Now check the other rules. Thumb rule, right hand thumb rule. Put this thumb along the direction of the current. Field lines are concentric circles. So at this point it is going inside the board. So at this point field is directed inside the board. Every rule will give you the same result. So you have to stick to one rule to find out. And if you are coming to this side for this current carrying wire, then at this point it is coming out. At this point it is going in. Clear? This direction. So I will start from the cross product only. So this is the magnetic field. Now at a distance r, this is at a perpendicular distance, so cross product angle is 90 degree. So we got all these things, so we can find this value of the magnetic field at this point. So magnetic field at this point will be simply B1. I write for the first wire. That will be mu naught I by 1 by 2 pi r. From the entire calculation it will come. You can find it from the result of Parseval's law also, or by using Ampere's circuital theorem. Ampere's circuital theorem will also give you this result. For a infinitely long straight current carrying wire, infinitely long, I have to put this one. Okay. So it will be mu naught I1 by 2 pi r at the position of I2. Now we can think of that second wire, which is carrying a current I2, is also an infinite current carrying wire, but it is placed in the magnetic field of the first wire. Second current carrying wire is placed in the magnetic field of the first wire, so it will experience a magnetic force. So how to calculate that force? So I consider an elemental length of the second wire. This one, suppose dl. So this is the elemental length of the second wire. What is the direction of dl? The direction of current is the direction of dl. Okay. Now for the second wire, what is the force? For this part df, suppose I2 dl cross B1. Because IDL cross B, that is the force on any current element. So we consider a current element of the second wire. That's why it is written as I2dl, and it is placed in the magnetic field of the first wire. At this point magnetic field is considered to be B1. B1 is there. Now, direction of B1 we have already determined, we will not use the direction anymore. Now, check. Put these 4 fingers along the direction of I2 dl. This is I2 dl. Like this. Not like this. Like this. Because after rotation, you have to go towards the direction of V1. If you put this one, you can't rotate and get the direction of V1. So you have to place this like it. Okay? Then what is the direction of V1? Into the board. Then rotate. Which direction thumb will show? Towards the first wire. So it will attract. So that's why two current carrying wire will attract each other. So this is the direction of the I2. So I2DL is along this direction and V1 is inward. So I2DL cross V1. This one cross. So thumb will show the direction towards the first wire. So that means this first wire will attract the second wire. This is the direction of VF. Clear? Towards the first wire.
Second, you explain it.
V1 for this on second wire, the magnetic field of the first wire is directed inward. I2DL is along the second current carrying wire. So I2DL cross V1 will give us the force on the current element DL. So I2DL inward. It is going inward. So which direction thumb direct? So this one is attracting.
So what is DL reverse?
Yes.
What is the direction of DL reverse?
No, not DL inward. DL is along the wire. P1 is inward. See, I1. It produces a V1 at this point. What is the direction of that V1? Inward. I2DL means along the wire. So I2DL cross V1. Cross V1 means this finger should be rolled towards V1. And in this case, what is the direction of the thumb? So this one will attract. Clear? Now, so if this one attracts, then I can calculate the magnitude. DF will be equal to I2DL V1 sin theta. What is the angle between V1 and I2? V1 is inward, I2 is over the board. So what is the angle? 90 degree. So DF will be I2DL. Now V1 means mu naught I1 by 2 pi r. Sin 90 is 1. So I can calculate DFDL, that is equal to mu naught I1 I2 by 2 pi r. So that is force per unit length. Force per unit length, that is mu naught I1 I2 by 2 pi r, where r is the distance between the two wires, parallel wires. Okay? Now, for this problem, you particularly start with this step, because this step you have to remember. Because in the exam there is not that time you will derive all these things and solve the problem. You have to remember this formula and proceed. Result, that deviation will become I1 plus I2 minus A. I1 plus I2 minus A, that is the deviation produced by a normal prism. Now, if we consider the normal prism and draw the diagram, then we can find this result of the thin prism. I will show you this diagram. This is the normal prism. So this is I1, this is R1, this is R2, this is I2, like this. This is it. This is prism angle capital. So while we will prove this one, I can write from this sine I1 by sine R1, that is equal to mu. For the Stein's law for the first surface, sine I1 by sine R1 equal to mu. Now, for thin prism, I1 and I2 both are very small. For thin prism, I1, I2 both are very small. So small angle approximation will give you, this is just equal to I1 by R1, that is equal to mu. So you can write I1 equal to mu times R1. I1 equal to mu times R1 for thin prism only. Okay. Now, for the second surface, similarly I can write sine R2 is the angle of incidence and I2 is the angle of refraction, that will be equal to 1 by mu. And similarly for thin prism, I can write R2 by I2, that is equal to 1 by mu, or I2 will become mu times R2. I2 will become mu times R2 for thin prism. Just substitute the value of I1 and I2 in the formula of delta. General formula, this one. So delta will become mu times R1 plus R2 minus capital A, mu times R1 plus R2 minus capital A. Just I substitute I1 equal to mu R1 and I2 equal to mu R2 and take mu common. But what is R1 plus R2 for a prism? It is equal to capital A, that prism angle. So delta will become mu A minus A. That is delta. So that is the formula for thin prism. So you have to remember this formula and directly start from this. Mu delta equal to mu minus 1 into capital E. Okay. Then second prism has to be adjusted like so that there will be no deviation. So both the prism together will produce zero deviation. Only dispersion will occur without any deviation. So second prism must produce the same deviation with a minus sign, such that the total deviation will become zero. And from that you can find the value of the prism angle for this second prism. That has to be calculated. Next question is, Polaroid is there or it is practical? Polaroid is there. Polarization, Polaroid. Okay. See, two Polaroids P1 and P2 are placed with their axis perpendicular to each other. Unpolarized light I0 is incident on P1, a third Polaroid P3 is kept between P1 and P2, that its axis makes an angle 45 degree with P1. The intensity transmitted light through P2 is. Which formula is required to solve this problem? Melas law. Melas law of polarization is required. So Melas law says that I equal to I0 cos square theta. I equal to I0 cos square theta. So from that you can solve this problem. Write this one as a hint, Melas law. I equal to I naught cos square theta. Okay. Next question, question number 23. Young's double slit experiment is first performed in air, then in medium other than air. It is found that 8 bright fringe in the medium lies where 5th dark fringe lies in air. The refractive index of the medium is nearly. So which formula you have to use? The formula for the distance of nth bright fringe from the central bright. Nth distance of nth order bright fringe from the central bright. That is xn equal to n lambda d by 2. N lambda d by 2. That you have to use. Young's double slit experiment, the distance of the nth order bright fringe from the central bright. That is calculated from this n lambda d by 2d. So using this formula you have to equate to find the refractive index of the other medium. So first what you will get a change in lambda. Change in lambda, if you can recognize, then from that you can get the ratio of, you can get the refractive index, because lambda is inversely proportional to the refractive index. So from that you can solve. Question number 24. The ratio of resolving power of an optical microscope for two wavelengths lambda 1 and lambda 2 is given. Ratio of the resolving power, how to calculate? So for each one calculate the resolving power and then take the ratio. It is from the diffraction part, the last part of diffraction. There is resolving power. Next one is, which of the following represents forward bias? Which of the following represents forward bias? Forward bias means P side is at higher potential than the N side. P side should be at higher potential. In which option P side is at higher potential? Option 4. See, P side is at 0 and N side is at -2. So that is P is at higher potential than N. So that is called forward bias, because in all the other cases P side is at lower potential than the N side. The transistor is already eliminated from the syllabus. Next is the given electrical network is equivalent to. Just you have to find out the truth table, then you can find. First one is a NOR gate, then followed by another NOR gate which is used as NOT gate. Not gate, then another NOT gate. First one, that is a NOR gate, followed by another NOR gate which is used as NOT gate, because two channels are same. Then after that there is a single input NOT gate. Then you have to write the logic equations, or you can write the truth table to identify which gate it is actually. Which one is the answer? It is NOR gate actually. Why? First one is NOR gate, then a NOR gate is used as NOT gate. so it will invert the result. Then another NOT gate, it will again invert the result. So if first one is producing an output for NOR, then it is second one is doing anti-NOR, then anti of the anti-NOR. So it is the original NOR gate will come. Question number 28. The photoelectric threshold wavelength of silver is 3250 into 10 to the power minus 10 meter. The velocity of the electron ejected from a silver surface by ultraviolet light of wavelength, this one. You have to use the Einstein's equation, half mv square equal to hc by lambda minus hg by lambda naught. Directly. hc by lambda minus hc by lambda naught, where lambda naught is the threshold wavelength and lambda is the wavelength of the incident light. From that you have to calculate directly. Next, 29. Two blocks A and B of masses 3 meter, masses 3m and m respectively are connected by a massless inextensible string. The whole system is suspended by a massless spring as shown in the figure. The magnitude of acceleration of A and B immediately after the string is cut. Immediately after the string is cut. Here. Immediately after the string is cut. Any idea? Anyone? Achha, can any one of you tell me if instead of string I cut the spring, then what will happen? Both will free fall. Both will free fall because the string will produce the tension on both the masses, so that can be considered as the internal force, and both masses will free fall only under the action of gravity. If instead of string I will cut the spring, but here the string is cut, so what will happen? So definitely their accelerations will not be same. So now check what happens. Masses are same 3m and m. See, initially all of them are in equilibrium. So what are the forces? mg, 3mg. These are the force by earth. Spring will exert a force on this. That is kx. String will apply same tension on both of these. The massless string, so it will pull both the masses towards its midpoint with tension T, and all these are in equilibrium. So equilibrium means Kx should be equal to T plus 3mg. T will be equal to mg. These are the two equations. Right? there is no cutting or anything, then Kx will balance T and 3 mg, and on the bottom mass T will be equal to mg. Then the system is in equilibrium. Now, so Kx is equal to 4 mg. I can write Kx will be equal to 4 mg in that case, eliminating T. Now the string is cut off. String is cut off. This one. Then when string is cut off, this mass will be in free fall. There is no tension on this mass. So this one is in free fall. So bottom mass has a downward acceleration g. The upward mass has two forces acting on it. One is kx, another is 3 mg. This one is absent now. So what is the net force on this? Kx minus 3 mg. So Kx will be 4 mg, downward direction, weight will be 3 mg. So this mass will experience a force in upward direction just when the string is cut off. So what is that force? Mg, because it is Kx minus 3 mg, that is equal to mg. This is the unbalanced force in the upward direction. And what will be its mass? 3m. So its acceleration will be mg divided by g by 3. So when just the string is cut off, then this mass will have a force in the upward direction, kx, downward direction, weight 3 mg, and kx is just we have calculated 4 mg. So what is the resultant force? That is mg in the upward direction. Its mass is 3m, so divide 3m to get the acceleration, and that will be g by 3 in upward. So when string is cut off, the mass 3m is momentarily going upward with acceleration g by 3, and other mass will fall downward with acceleration g. But if spring is cut off, entire system will fall with acceleration g in downward direction. Question number 30. One end of a string of length L is connected to a particle of mass m, and the other end is connected to a small peg of a smooth horizontal table. If the particle moves in a circle of with speed v, the net force of the particle directed towards center will be. What is the net force? This one is easy. Tell me, what is the net force? 1 is 0. Acceleration is 0. Actually, the v square by L centimeter. What is the net force towards the center? Acha, tell me, which force is acting towards the center? Tension, Western pulsing, and which force? Centripetal. So how many forces are there towards center? 2 forces. So what will be your answer? T plus mv square by L. Completely wrong. What is the real force towards the center? Tension. Tension produces this centripetal acceleration. So the only force is towards center that is behaving like centripetal force is tension. So it is the only force. If you remember when we discussed circular motion, I said that if a particle is moving in a circle, then any real force acting towards the center is behaving like centripetal force, and that produces the acceleration v square by r. Then following Newton's second law, I can write that force will be equal to m into v square by r. Then there is no other force which is specially categorized as centripetal force. Any real force will behave as a centripetal force to provide centripetal acceleration. Okay, so here tension is the only real force towards center which produces this centripetal acceleration. So don't write centripetal force is there and tension force is there. Tension is itself playing the role of centripetal force. Two disks of same moment of inertia rotating about their regular axis passing through center and perpendicular to the plane of disk with angular velocities omega 1 and omega 2. They are brought into contact face to face coinciding the axis of rotation. The expression for loss in energy during this process. Why energy will loss? Why energy is lost? They are saying that energy will loss. Why it will loss? General form of rotational kinetic energy is half I omega square. So now see, if you change the axis of rotation, then moment of inertia will change. Moment of inertia will change, and once moment of inertia will change, keeping the angular speed same, then in that case, total energy will change. So from that, they are arguing that there is a loss in energy, and from that you have to calculate. Okay, keeping speed of rotation same, if you change the axis, then moment of inertia will definitely change. But it is not mentioned whether in general angular speed is remain constant or not. It may happen that angular speed will also change. So in general, both the quantities will change in somehow that there is a change in total energy. So that you have to calculate. Two astronauts are floating in gravitational free space after having lost contact with their spaceship. The two will move towards each other, move away from each other, will become stationary, keep floating at the same distance between them. Which one is correct? What will happen? The fifth option should be there, they will die. So with this fourth option, what will be the answer? They will move towards each other because of the mutual gravitational force between their bodies. There will be mutual gravitation. If it is truly gravity-free space, truly gravity-free, which is not possible actually. So if it is truly gravity-free space, then due to their each masses, they will attract each other and they will move towards each other. Question number 33. The acceleration due to gravity at a height 1 kilometer above the earth is the same as at a depth d below the surface of earth. Then b equal. First you have to find the value of acceleration due to gravity at a height of 1 kilometer above the earth's surface. Then putting that value in the acceleration due to gravity for depth to find the depth. First you have to use this formula G prime, that is equal to G r square by r plus h whole square, where h should be 1 kilometer. From that you can calculate G prime and then consider G double prime equal to G into 1 minus 2h by r, and in G double prime put this value. Is in radius. Fractional decrease in radius is. How to calculate? Calculating the bulk modulus. B equal to minus P by dP by V, where P is the pressure called the volume stress, and dP by V is the change in volume per unit volume, original volume, which is called volume strain. So bulk modulus is defined by ratio of volume stress by volume strain. Volume stress is pressure and volume strain means dP by V. The minus sign is used because if you increase pressure, the volume will decrease. That's why the minus sign will come. Okay. Now, In this case, it is given that the bulk modulus of the object is B. If it is subjected to a uniform pressure, the fractional decrease in radius you have to find out. Okay. Now the object is spherical, so we can write that its volume V will be equal to 4/3 pi r cube. Volume V will be 4/3 pi r cube. So first take a logarithm, log V, that will be log of 4/3 pi plus 3 log r. Log V equal to log of 4/3 pi plus 3 log r. Okay, now differentiate both sides. It will be dV by V. This one is differentiation will be 0. This one will be 3 times dr by r. 3 times dr by r. Okay. Now, in place of dV by V, I can substitute 3 dr by r. Minus P divided by 3 dr by r. So dr by r will be equal to minus P by 3b. The minus sign is for the loss, decrease. So option 3 is correct. Option 3, P by 3b. Minus sign comes from the decrease in the calculation. Since it is given spherical object, so V should be equal to 4/3 pi r cube. Differentiate both sides to get dV by V. Fractional change in volume equal to 3 times fractional change in radius. Then dV by V is replaced by 3 dr by r. So dr by r will be equal to 3 P by 3. Okay. A gas mixture consists of 2 moles of oxygen and 4 moles of argon at temperature T. Neglecting the vibrational modes, the total internal energy of the system. From which one you can calculate? First you have to find the total number of degrees of freedom. Then in each degrees of freedom, the energy distributed is half kT. Half kT. Then from that you can calculate. Because law of equipartition of energy says that in each degrees of freedom, energy is equally divided and it is equal to half kT for each degree of freedom. Okay. So first you have to find out degrees of freedom, then multiply it with half kT. Question number 36. A particle executes linear simple harmonic motion with an amplitude of 3 cm. When the particle is at 2 cm from mean position, the magnitude of its velocity is equal to that of its acceleration. Then its time period in seconds is which one? For SHM, velocity can be calculated as where A is the amplitude, x is the displacement, v is velocity, and omega is the that circular frequency. Then acceleration I write only the magnitude of acceleration at any moment. Because if you put the sign of acceleration, then it will be minus omega square x. I put only the magnitude, a equal to omega square x. Now it is said that at 2 seconds, when the particle is at 2 centimeter from the mean position, the magnitude of velocity is equal to that of acceleration. So when I put x equal to 2, then v and a will be equal in magnitude. Capital A is given. From that you can find omega. Equating these two, you can find omega. How? Omega square x is then equal to omega root over of a square minus x square. Clear? When this x will be equal to 2 and amplitude will be equal to 3. So in place of x now I can put omega square. 1 omega square will cancel. It is 2. It is equal to root over of 3 square, means 9 minus 4. So omega square equal to root over of 5 by 2. Omega square will be equal to root over of 5 by 2. Then you have to, sorry, not omega square, it's omega. That's it. Now omega means 2 pi by t, root 5 by 2. Then calculate the time period. Time period t will be 4 pi by root 5. This is the formula for velocity of a particle in SHM. That is v equal to omega root over of s square minus x square. Magnitude of acceleration is equal to omega square x. Then it is said that at a particular value of displacement, that is 2 centimeter, magnitude of velocity and magnitude of accelerations are equal. So I equate both these of them. Then x for that value is given 2. Amplitude is given 3. So I put the value 3 square minus 2 square, then find omega. Omega equal to 2 pi by t, that is time period. Next question. A string of force constant K is cut into lengths of ratio 1:2:3. They are connected in series and the new constant is K prime. Then they are connected in parallel and the force constant is K double prime. Then K prime is to K double prime. How to find this one? The force constant of a spring is inversely proportional to length or directly proportional to length? Inversely proportional to length. So if they are cutted, then their length will be decreased and as a result the constant will increase. Then calculate the new constants and then connect them in series and parallel and calculate and take the ratio. If the spring is cut into parts, then their force constant will increase. Force constant will increase because changing force constant is inversely proportional to the length. So if length is decreased, then force constant will increase. Then find the 3 individual parts new constant, force constant. Then first connect them in series to calculate K prime. Then connect them in parallel to calculate K double prime, then take the ratio. That is the entire problem. Next, suppose the change of a charge of a proton and an electron differs slightly. Okay, one of them is minus E and other one is E plus delta E. If the net electrostatic force and gravitational force between two hydrogen atoms placed at a distance d much greater than atomic size apart is 0. Then delta E is of the order of given mass of the hydrogen. Okay. So first what you have to do? First you have to consider that gravitational force will attract each other and electrostatic force, due to electrostatic force they will repel each other, and consider that they will cancel each other. So in that case magnitude of gravitational force should be equal to magnitude of the electrostatic repulsion. From that you have to calculate the value of delta E. So equating that force, the equation will come, and from that you have to calculate the value of delta E. The diagram below shows regions of equipotentials. A positive charge is moved from A to B in the diagram. In all the four cases, the work done is the same. Minimum work is required to move Q in figure 1. Minimum work is required to move Q in figure 2. Maximum work is required to move Q in figure 3. Which one is correct option? Tell. Which one? Why say? না তুই পরিমিশাল তো নিয়ে যাচ্ছে না 20 থেকে 40 নিয়ে যাচ্ছে একটা 20 ওপর দিয়ে মুভ করা দেখছিস See, don't think that the charge is moving over the equipotential surface. Then its A and B, both the points should be on the same line. But it is going from one equipotential surface to another equipotential surface. So work done is not zero. Now the question is the work done same or different? Same, because it is not zero. It is same because potential difference is in either case. In all the cases, potential difference is 20 volt. Because initial potential is 20, final potential is 40. So they are traveling through a potential difference of 20 volt. Same charge. Charge into potential difference is what done? So W equal to Q into V2 minus V1. Charge is same. Potential difference V2 minus V1 in all the cases are 20. So work done should be same. So in all the four cases, work done is the same. That is the correct. Next one is a question of earth magnetism. That is actually a proof. It will come in the form of cot square theta I think. Cot square theta equal to cot square theta 1 plus cot square theta 2. That is a proof. But earth magnetism is there. So So that angle of deep portion that you have to study, and in any textbook if you find, you will get this formula. This is just a formula of earth magnetism. Question number 41. A long solenoid of diameter 0.1 meter has 2 into 10 to the power 4 turns per meter. At the center of the solenoid, a coil of 100 turns and radius 0.1 meter is placed. With its axis coinciding with the solenoid axis, the current in the solenoid reduces to a constant rate to 0 from 4 ampere in 0.05 second. If the resistance of the coil is 10 pi square ohm, the total charge flowing through the coil during this time is. Which topic's question? Electromagnetic induction. Because if there is a change in the current in the primary coil, then there is also a change in flux in the secondary coil. So in terms of mutual inductance, you have to calculate. Mutual inductance, which depends on the number of turns of both the coils. So due to the mutual inductance, there is a change in the flux in the secondary coil also, and which is followed by a net change in the flow of charge to the secondary coil. So from that calculation you can solve. Because first coil produces a magnetic field in its core, so there is a second coil inside the core. So through this first coil magnetic field lines will pass. So there is a flux associated to the secondary coil which is at the core. So if the current in the first coil is changed, means the magnetic field will change, which will produce a change in flux in the secondary coil. So that uses the mutual induction, and as a result there is a flow of charge will be hampered, and that can be calculated. Next, a beam of light from a source L is incident normally on a plane mirror fixed at a certain distance x from the source. The beam is reflected back as a spot on a scale placed just above the source L. When the mirror is rotated through a small angle theta, the spot of the light is found to move through a distance y on the scale. The angle theta is given by. See, you have to start from this, that whenever a mirror is rotated, a reflected ray will rotate at an angle to theta. If the mirror is rotated at an angle theta, you have this in your class 12 syllabus, reflection. When a plane mirror light is falling on a plane mirror and reflected, if I rotate the mirror by theta, reflected ray will rotate at an angle to theta. So from y and x you have to consider, you have to find that. That angle theta has to be measured in terms of y and x, because then it will form a right angle triangle, and from that you can argue. Next one is the de Broglie wavelength of a neutron in thermal equilibrium with heavy water at temperature T, Kelvin and mass. So de Broglie wavelength of neutron in thermal equilibrium with heavy water. How to calculate? Because first you have to calculate the de Broglie wavelength. Start with the de Broglie wavelength formula, that is lambda equal to h by p. But P can be written as root over of 2m into kinetic energy. Then kinetic energy can be calculated in terms of kT. Following the equipartition and these things, you can calculate kinetic energy in terms of kT. Boltzmann constant into temperature and Kelvin scale. So from that you have to solve this one. Next one is the radio wavelengths of the last of the ratio of wavelengths of the last line of the Balmer series and the last line of the Lyman series. So you have to calculate from the formula of Rydberg formula. Last one, radioactivity, not there. Radioactivity is also eliminated. রেডিওঅ্যাক্টিভ নাই তো আর্থ ম্যাগনেটিজম বলি তাহলে আর্থ ম্যাগনেটিজম Earth magnetism, radioactivity, all these are not. And C amplifier, transistor, these portions are not there in the syllabus. Start to prepare the notes of these papers. Even if the complete solution you cannot attempt right now, start prepare the notes and show it to me before I leave in this session. Okay, I will leave on 5th. So before within 4th of September, try to show me the notes that you have prepared for the paper that I have discussed yesterday's class, today's class. I will try to take 3 to 4 up to 7, whatever be the exam you have given. I want to discuss the paper such that at least 2 to 3 paper notes you can complete, and I will check that before I start reviewing this test.